All right. So you might ask, well, we're doing circles and you're asking us about lines, Burkhead, but I'm trying to show a connection. In a line is a spectacular geometric object, and every line has an equation. And that equation gives you the power to identify the slope quickly, the y-intercept. You could even identify the x-intercept. You can identify multiple points on that line. Here in this instance, B has coordinates 0, 4, so the y-intercept is 4. The slope of the line, well, from this point B to A, I have to go down 3 and to the left 4, so that would be a negative 3 divided by negative 4, that's 3/4, which is a 0.75 slope. So y equals 0.75x plus 4 is that equation. And that's helpful in a computer realm. I could measure the equation, and lo and behold, we get the same equation that I just developed. And that equation is so powerful, because when x is, let's take 4, when x is 4, I'd have the value 7, because 3/4 of 4 is 3, plus 4, so that's going to be 7. And look, here's 4, and look, it goes to the point 4, 7. Don't you love that? So that line can give you a lot of information, the equation. Well, if we run to the circle, we developed in class, using the distance formula, we said r was equal to, and then we just said that this point here is some random point, x, x sub 2 or xy, x minus h quantity square plus y minus k quantity square is equal to r square. And you all walked me through that, and it's a very powerful thing. Well, in this instance, we have a center. It looks like 1, 2, 3, 4, 5, 6. We go 6, 1, 2, 3, 4, 5. So we have a center 6, 5. So I'm going to replace my h with 6, and I'm going to replace my k with 5, and my radius, well, that might be a little bit more difficult to find out, but we can find it. Why don't we go to a grid point? Do you see how this is 2 and this is 2? Wouldn't that have to be 2 root 2? So the radius is 2 square root of 2. Well, if I square that, because I have r square, well, that 2 square root of 2 is 2 squared times 2, which is 4. Times 2 is 8. So that's going to be 8. Now, if we think about the plugging any point, any of these points, if I measure the x-coordinate of that point, and I measure the y-coordinate of that point, and I were to take, and I'm just going to take my parameters 6, you see a value 6, and you see a value 5. Any time that I take the quantity, this x minus this 6, and I square it, and I add this y minus this center y coordinate, and I square it, I'm going to get 8. Do you see that? And why would that be helpful? Well, what if we don't know these points here, or we know one of the coordinates? We could plug that in and find the other coordinate with that equation. That's one of the reasons that you might want to work with an equation of a circle. As well, you might want to find the intersection of two circles. Well, could you set those the equations of those two circles equal to one another? I think so. Now, this is another basic geometry thing you need to be able to do. You need to be able to go backwards, saying, write an equation of a circle with radius 7 and center 4, negative 5. Well, I'm just going to copy that because I just don't like to type too much. But instead of my 6 and 5, I have a center of 4, negative 5. Well, that's going to be a minus 5. And last time I checked, that's going to be a plus 5. And then the radius is 7. Remember, the equation is x minus h quantity square plus y minus k quantity square is equal to r square. So we would have that 49. That's an equation of that circle. And I'm willing to put down big money that if I were to, with my calculator here, go and plot create a circle. Let's first set up some parameters, 4, and then set up the parameter -5. Plot the point 4, -5. Yeah, that makes sense. And then create a circle that has radius 7 with that center. Boom! I'm willing to put down big money that when I ask the computer, hey circle, what's your equation? Sketchpad is going to tell me the same thing. And look, it does. That's powerful. Now your OIS, the first part, asks you to find equations of different circles. Well, let's call this circle 1, this circle 2, and this circle 3. What's cool about the assignment is there are some congruent circles. So your radius is going to be the same. You'll just change your center. Well, the first thing I would do is I would identify the coordinates of the center. So in this world, my center has coordinates. It looks like here's a -12, 1, 2, 3, 4, 5, 6. -12, and I'd go up 6. Now, my radius might be a little bit more problematic, but I'm up for the challenge. What you want to do is get an actual point on the circle. Do you see right there where the grid point actually is on the circle? And then you just want to either use the distance formula. You know, this point has coordinates 12, 6. This point has coordinates -11, 3. So I'm just going to copy 12, 6. Okay, 12, 6. And this point has coordinates, I think I said, -11, 3. So we can use the theorem of Pythagoras or the distance formula. This little side of that right triangle, if y'all want me to make the right triangle, I will. Oh, I can't. I'm not on Snap to Grid. But if I wanted to make my right triangle, I would go there. I have a 3, 1. So 3 square plus 1 square. Well, that's 9 plus 1, 10. So this radius is the square root of 10. Don't be worried that you have a radical sign, because remember, your equation is x minus the h, which is the x coordinate of the center, and y plus y minus k, which is the k is the y coordinate of the center, equals r squared. So you don't even have to be intimidated by the square root of 10. You're just going to have the following: x minus 12, so that's going to be x plus 12, quantity square, plus y minus 6 equals square root of 10 squared. Well, that's a whopping and beautiful 10. Now, can you see that this circle that I'm selecting here is congruent to this circle here? So we have the same radius. We just need to identify the C. The C is the center. So the center here is 0, 3. So the equation of my circle would be what? I have x minus 0. Well, x minus 0 is x. And y would minus 3. So I'd have x squared plus y minus 3 equals that beautimous 10. Another example? Well, I think I've caught on to this little game. I think it's helpful to write that center. The center has coordinates 10, it looks like 5. And let's take a look. This here is 4, this is 3. Oh, Burkhead, you were nice. 3, 4, 5. Oh, I'm just a sweetheart. So there's your equation of your circle. If my center's 10, 5, I have x minus 10, y minus 5, and it's going to be 5 squared, which is 25. If you wanted to put 5 squared, that's fine. The beautimous part is we can check our work all at the same time. I select these círculos, that's Spanish for circle, and I measure those equations. And circle 1, oh, circle 2, oh yeah. Ooh, wait a second, circle 2, oh, and circle 3, oh yeah. You see how that matches? Now, why does circle 1 and circle 2 have a different representation of 10? Well, guess what? If I were to take 3.16228 to the second, oh my, it's approximately 10. So there's a little computer glitch in my work here, but that's totally just the computer glitch. And you see that if we were to round to the nearest 10,000, I guess, let's see about that. That's 10, 100,000, 10,000. Yeah, we'd be in business. We would have the beautiful circle that we want. I sure hope this helped. Come see me during tea period if you still have questions.